All right, welcome back, folks. Quickly from one into another, our second from last speech of the day. We've got Catalin here to teach us about ways to deploy Azure resources in an automated manner. Catalin, take it away.
Thank you, Darren, for your presentation, and I'll go straight into it. So for that, I'm going to share my screen to you guys so that we can dive right into it and talk a bit about ways to deploy Azure resources in an automated manner. I'm going to tell you for the start, the session is going to be interactive, meaning that we will also do some demos along the way. So I don't really have much slides that I can present to you guys. It will be basically kind of a debate. I'm going to show you what you can do with ARM templates. I'm going to show you what you can do with Terraform, or I'm going to show you what you can do with Bicep. And then we're going to try to draw some conclusions all together to see when you can use them, how you can use them, which one is better off in which circumstances, and so on and so forth. So probably for some of you guys who are already a bit knowledgeable in terms of infrastructure as code, we're going to talk about that as well, why you should use it and what are the benefits of it. I'm sure at least one time in your life you had a debate or you've seen the debate of what's better, Terraform or the Microsoft tools ARM or Bicep. So this session is basically just a kind of an intro to all three of them. We'll see the different ways on how we can do deployments, and then we'll basically make a summary.
Well,
But
Catalin,
yeah,
can you maybe stick the presentation in presentation mode just because
yeah,
like some people have smaller monitors?
sure, no worries. Give
Thank
me
you.
1 second from beginning, and I'm gonna change the slides. Now it should be better, right?
Fabulous. Thank you very much.
Perfect. Cool. Before I dive right into it, let me make a small introduction as well. I'm Catalin. I've been working with Azure for almost 9 years, actually. Yeah, from 2014. So I'm going on 9 years, I guess. I first interacted with Azure when I was working at Microsoft as an engineer. That's where I actually started putting my putting my hands and playing with Azure. Let's go like that. After 4 intense years at Microsoft, where I was an engineer, a business development manager, and at some point a cloud solutions architect, I decided to start my own company with two other colleagues from Microsoft called Adaptive Run. And from that point on, which was end of 2017, that's what we're basically doing. Professional services, going from project to project all around the world, implementing Azure solutions to enterprise customers mostly, and also governments as well, right? So we had a bunch of projects along the way, and I've had a bunch of projects along the way, which were pretty interesting. That's why you see also all of those certifications and all of those awards on my name. Playing with Azure for 9 years straight, and also being a purely Microsoft guy can take you and have this portfolio of awards and certifications. But enough about me. Let's dive right into it because we have 45 minutes in total. So I really want to get to the interesting points. The agenda is pretty concise, right? We're gonna talk about infrastructure as code. We'll see what's the deal with it, what you can do with infrastructure as code, basically. Then we're gonna take one technology at a time. We're gonna talk a bit about ARM templates, see let's say the main reasons why ARM templates are being used or what you can do with them, and we're gonna also demo them into a live exercise. Same thing we're gonna do with Terraform. We're gonna present some bullet points here, and then we're gonna go and do a deployment Terraform-wise and gonna build some things in Azure. And then the same thing with Bicep, right? And afterwards, after we see all of these free ways of deployment, all of these free technologies, we're going to try to make a summary and a comparison and draw some conclusions. At the end, of course, the Q&A session in which you guys can, of course, spark up the debate and ask about whatever you guys want to ask in terms of these technologies. So first things first, infrastructure as code. In really short terms is basically you can manage and provision infrastructure through code instead of doing through a manual process, right? When it comes to the cloud, not just Azure, right? So if you think in general manner, when it comes to the cloud, you usually have 2 or 3 manners in which you can actually create resources. You can do it the classic way, in which you go to a portal, even if it's Azure, even if it's AWS, even if it's Google Cloud, and so on and so forth, and you start doing clicks and you start building resources like I don't know, virtual machines or virtual networks or web apps or so on and so forth. It's the manual way of doing it, let's call it like that, right? In which you basically just rely on the UI to create resources. Now, at some point, you might want to do this in, let's say, a more programmatic manner, right? So instead of actually doing clicks in the portal, you can rely on infrastructure as code, in which you can go code in a certain language. In our case, that we're going to present ARM templates, Bicep, or Terraform, and you can transform that code directly into resources in the cloud, in Azure, in our case. Why would you do that? Well, you see on the screen some of the benefits why infrastructure as code is actually preferred by most of the DevOps engineers and most of the infrastructure engineers. Actually, first of all, it reduces errors. I mean, if you do an error on your code, of course it will show up into your infrastructure when you deploy it, but it's easier to correct it from a code perspective, and then afterwards when you redeploy it and redeploy it and redeploy it, it will not happen anymore. If you do it manually, of course, at a certain point, you're more error prone because you might forget a certain configuration, or you might forget a certain service or a certain subservice that you need to create. Right. Second of all, cost reduction, and it's really tied up with the idea of increasing the speed of deployments. Although it might take a while to develop your infrastructure as code, to develop your code to building infrastructure. Once you've done it, basically you just have to run that code and you'll spin up environments in no time, right? Which, of course, time means money in all the universes, I guess. So it's probably easier to spin up an environment by just running a code and then letting the infrastructure as code do its job in like 10 minutes than creating things manually, which will probably take up hours, if not days. Just think of the following example. I always take this example, right? Imagine you have to build 100 VMs of different configurations. If you do it manually in a portal, that will kind of take some time because you have to do a lot of clicks to actually do it, right? If you want to do it via code, and I'm talking here not just infrastructure as code, you can also PowerShell it, you can also CLI it, use a command line interface, and so on and so forth. It'll probably take you about 10 minutes to script that thing, then run it with about 20 or 30 minutes more, and you'll have 100 VMs in your cloud, right? So it's really more effective from a time perspective and also from a cost perspective. The fourth one, actually, improve infrastructure consistency. It's actually tied with the first one of reducing error. Once you've built your code, you're pretty sure that the second time you want to spin up the same environment, it will actually be the same environment, right? So it will not be subject to any changes that you've did manually, because at the end of the day, the code will be the same, right? So you'll have consistency. If you want to spin up environment A, right, and then you want a copy of environment A into a different subscription or a different tenant in Azure, you can just take the ARM template and you'll build, or the Terraform file or the Bicep template, and you'll build the same thing, right? And last but not least, eliminate configuration drift. Also a bit related to the other ones that I just mentioned. Of course, you can do certain configurations along the way, even manually. I mean, after you build all of your infrastructure via infrastructure as code, of course, you can do some manual stuff. But if you want at a certain point to revert back to the initial configurations, you can just rerun your infrastructure as code to go to, let's say, the fabric settings, right, as you have it on your phone. So at a certain point, if you want to undo or redo what you've just coded, you can also rely on that. So it has its perks. I'm pretty sure that most of you who have interacted with infrastructure as code already know what I'm talking about. It doesn't need any large presentation on it. Of course, whatever it's coded and it's in a programmatic manner, it's more beneficial than doing it manually. Now, when it comes to Azure, as I said, you have three ways of doing it. First is the ARM templates, in which basically this is the backbone of Azure. You'll see that everything that is built in Azure is translated to ARM. Even if you're doing via Terraform, even if you're doing it through Bicep, you'll see in just a GIF what I mean. At the end of the day, whatever you build in Azure, it will be ARM related. This is basically the technology that Azure is built on, is the backbone of Azure, and whatever it's in the backend, it's all ARM templates. If you build it via Terraform, or even if you build it via Bicep, these two other tools are basically just a up top layer on the ARM, which basically translates ARM to the other languages. But at the end of the day, in the backend, when you finish deployments, you'll see that every resource in Azure is basically ARM template based. And we'll see that in just a bit. Jeff. Now, in terms of syntax, the syntax, you'll also see it live because we're going to do a demo. Is a bit complicated, meaning that is a pretty complicated JSON structure, which of course comes with all the bells and whistles, meaning that you have a lot of extra characters that usually programmers don't really like. You'll see it kind of hurts the eyes when you look at it, but oh well, it has pros and cons, I guess. Then in terms of syntax also, it's declarative, meaning that whatever you put in your script, that's what you will build. If you have a block that you declare to build a storage account, it will build a storage account. If you have a block that declares that it will create a virtual machine, it will create a virtual machine, and so on and so forth, right? So it's declarative. Well, it's also extensible. I've also listed this as a trait of ARM templates, because you'll see that in the other languages, it might be or not might be a trait as well, meaning that on ARM templates, you can also execute PowerShell or Bash scripts, right? At a certain point, especially in, let's say, more complicated deployments, you might feel the need, or you might have the need to do some, let's say, post-deployment activities, right? You build the infrastructure, and then because you cannot control it through infrastructure as code, for different reasons, it might happen. It usually happens. I'm going to be honest with you, right? I'm going to give you an example of the most classic probably scenario. You need to execute a PowerShell script. Just think about deploying a solution that has to host an application, right? You build a web app, and that relies in the backend on a SQL server, on a SQL database, right? And then at the end, when you're deploying the infrastructure as code, you want to push also the application code, which you can do via a pipeline in DevOps, but you also want to, populate the database with some data, not pushing a DACPAC file, but running a PowerShell script that will, add an extra line into the SQL database or something like that. Well, if you want to do it all from an ARM template, of course, and you don't want to have a pretty complicated pipeline in your DevOps, you can also do that as well in ARM templates. That's just one of the scenarios. Desired state configuration on virtual machines goes on in the same manner. You build a VM, and then if you want to execute PowerShell scripts in the VM, you will want to use this, right? So think about that when it comes to deployments. Modular files means that you don't need to have one file to deploy your whole infrastructure. Basically, this is a trait that's probably pretty common in programming in general. I mean, usually nowadays, when it comes to infrastructure as code, you would have multiple files that will be then summed up into a parent file, let's call it like that, into a nested template. That's how it's called in ARM, where you basically deploy all you need to deploy. I'm going to give you the following example. Let's presume you want to create a storage account, you want to create a virtual machine, and you want to create a SQL database. Instead of putting all of these three blocks into one big file, you can build a file for the SQL, you can build a file for the VM, and you can build a file for the storage account. And then you can call up those files, those modules, right, into a parent file so that you can deploy whatever you need to deploy. Why would you do it like that? The reason is pretty simple. If you want to reuse at a certain point modules from different projects or from different scenarios, you can easily do so. You can build your own, let's say, database of modules, your own, let's say, archive of modules, and then when you need to deploy different solutions, you can just fetch one of the modules from there, nest it into your parent file. That's about it. Then we go further on, and we're going to see that the ARM templates are actually deployments that are tracked. It's better shown than said. Basically, you're going to see it when we do the demo in just a GIF. when you deploy ARM templates, you're going to see in Azure as well in live mode how those resources are being deployed and also the errors that come up, which in some of the other tools that we're going to present here, it's a thing that we that it's not supported. It also supports incremental deployments, also better shown than said, and we're going to get to it right to it. If at a certain point you ever want to do changes in a manual manner or not through the ARM template that you want to deploy, basically the ARM template doesn't really care about that. ARM templates just go and deploy resources independently of what's in Azure at the moment. So for example, if you have a storage account already built in a manual manner through PowerShell, whatever it's like, if you apply an ARM template, which basically just changes one of the configurations, the ARM template will actually do that, which can be a pro or a con depending on what you're trying to achieve. And we'll see it in action as well. And the last one, it's regarding dependency, which is a pretty big deal in terms of infrastructure as code. But enough said than done. I'm actually going to share my screen again. And I'm going to go into Azure, in which I've built up a pretty small shop, a demo shop, let's call it like that, in which I have a blank subscription, right? My Visual Studio subscription. And I have here also as well a blank resource group. So basically it's kind of a blank Azure tenant, if you want to call it like that, right? In which we will build some of the things in Azure through ARM templates. Now, I'm also having a DevOps environment, an Azure DevOps environment, in which you can see it's pretty simple. I've prepared some files so that I can show you guys all of the free technologies that we're going to talk about: ARM templates, Terraform, and Bicep. And here in each folder, I'm going to start with ARM. I basically have a small file on each. You'll see that on Bicep I have one as well, in Terraform one as well, in which we're building some resources. What resources more specifically? I'm building a storage account here. You can see it from the type, right? Microsoft storage account. I'm building an app service plan, Microsoft.web server farms. And then I'm also building a web app on that server farm, right? In which I'm building that app, which relies on the app service plan. Also, sorry for that, I forgot to mention, on the storage account that I'm building here, sorry, this is the block, I'm also building a file share inside the storage. It's a pretty simple example. The reason why I chose to build these resources are, first of all, they build pretty quickly. It takes about 1 minute, 2 minutes tops to build all four of them. And they also have some dependencies between them. Remember that at a certain point I mentioned dependencies, right? These depend one on another, right? So you have to, in order to build a file share, you'll have to have the storage account first built, of course. And in order to build the web app, at a certain point, you'll have to build the server farm, the app service plan, right? So talking about deploying it, in my pipelines, I also have some release pipelines, simple ones, in which it's going to make a deployment of my ARM template. I'm going to show you really quickly how the pipeline actually looks like. It's the most basic pipeline that you can ever imagine in DevOps, for the sake of the demo, of course. Basically, a CD pipeline, a release pipeline, in which is pointing directly to my repo, to my sandbox repo. From here, I just have one stage which has only one task, an ARM template deployment. And the ARM template deployment relies on a service connection, which is linked to my subscription here. I'm going to show you that as well in just a GIF, this cog SPN, right? Pointing to the subscription that I was just mentioning, right? This 2349 ending in 622, exactly the same subscription that you see here. The action would be creating or updating a resource group. The resource group will be DevOps Pro Europe demo, exactly as we have here, right? And then we're pointing at that ARM template that we have in our repo. Very simple, very clean, basically just to show off what ARM templates are doing. So I'm going to actually hit up the release button and I'm going to create the resources. And while the resources are being created, we're gonna talk about some of the traits that I've been showing to you guys into my PowerPoint. It's gonna take a bit until Microsoft, of course, gives me an agent. But meanwhile, until it gives me an agent, I'm gonna duplicate it, and I want to first look a bit on the syntax that we have on our template. You probably already viewed it, and you've already seen that it's a bit complicated in terms of how it looks like, right? With all the bells and whistles, with that crazy JSON structure that it has, right? So a lot of commas, a lot of parentheses, and so on and so forth. It's not that hard to, of course, to read, but at the end of the day, if you're starting from scratch and trying to build it / code it yourself, it's going to give you a hard time, right? One small comma that you miss and your ARM template won't work, and so on and so forth, right? So it's, in terms of syntax, pretty complicated and also pretty long, right? I'm creating 4 resources, and all of the resources take me about 80 lines, and these are the easy resources, let's call it. Meanwhile, my pipeline is running. It's also finished already, right? And if I go to Azure, I can see that my resources are already spinning up. I also want to show to you guys that the tracked deployments that I was talking about here, right? This tracked deployments part is showing up in Azure as well. You can see that this deployment, which has the name, whatever, right? Today's date and a random string, shows me that I've built the following resources. If I go to deployment details, I can see that I've built a web app, the file share, the app service plan, and the storage account, which if I then go to the resource group, I can see all 4 resources free here, right? The web app, the app service plan, and the storage account. And if I go inside the storage account, and if I go to file shares, I should also see a file share named very preemptively file share, right? So it goes pretty quickly. When it comes to the traits that we're talking about here, sorry for that. Let me swap it again. Right, syntax pretty complicated, declarative, as you've seen. I'm basically putting a block for each resource that I'm trying to build. Modular files, I didn't demo that to you guys, but just keep in mind that if I want to have 1 file per each block, I can actually do that. Right, track deployments is basically related to the thing that you've seen here into deployments, and this is real mode. I mean, if you look at it as the deployment goes through, for me, it just finished because it's pretty quickly. It takes about 50 seconds. You can actually see how the resources are being built in real time. You'll see here, instead of succeeded, instead of status okay created, you'll see creating or whatever, right? Whatever the status might be. So that's about it. Also about incremental, the last and most important point when it comes to ARM, I guess. I'm going to show you pretty quickly what that means. If I go into the portal, I have the resources now already built, right? If I go and change something on my storage account, let's presume I want to change something in the configuration pretty quickly, right? Let's access on the blob, and I also don't want to allow storage account key access. Let's put it like that, right? I'm going to disable those. If I run again my pipeline, if I deploy again, you'll see that basically the deployment will go through. We'll confirm that the resources are already there, and we'll try to rebuild them, of course, but it will not change what I've just changed manually, which can be a pro and a con. And I'm going to show you why I say that when I'm going to talk to you guys about the Terraform part. So let's wait for the pipeline to run. This time I can also show you how the tracked deployments are actually looking like from a live perspective. Okay, initializing the job, downloading the artifacts, and then going to the ARM template deployment. It gave me a name, right? 82856, whatever. If I go to deployments, you'll see that I have a new deployment, which is deploying. And it shows me what's already being built around here, right? Already built, finished again. If I go to my storage account, here, and if I the configurations that I just made a few seconds ago, you'll see they're not changed, right? So ARM template doesn't really care what you do. As long as it's not specified into the code, it will not have a problem with that. It will basically not touch the configurations or the resources that you have manually created or manually changed in Azure, right? Only if I would have specified here into the storage accounts block that the blob public access needs to be in a certain manner, true or false, then it would have changed it back. But as long as it's not mentioned here or in any other block, doesn't really care about it, right? Cool. So that's with ARM templates. Going further, and I'm going to continue with Terraform, which is a bit different. Terraform, let me change the slides again to swap it. So when it comes to Terraform, I have to share you a bit of history. First, there was ARM templates, let's call it like that, in Azure. And then because of the syntax and because of the crazy dependencies that you have to mention in Azure, also you have to mention in Azure in general and also in ARM templates, then HashiCorp, the creators of Terraform, right, created a third-party tool which basically acts as an additional layer on top of Azure. What Terraform actually does, it created its own syntax, which is a lot easier, a lot more understandable, a lot more, let's say, pleasant to the eye, a lot easier to declare as well. You'll see that in just a GIF. And also got rid of dependencies mostly. And also you can use Terraform for other clouds as well. It will be the same language, not the same, of course, not the same blocks. But if you want to deploy, for example, AWS, or if you want to deploy in Google Cloud, or if you want to deploy in Azure, you can use Terraform. Different blocks, of course, different types of resources that you need to build. But at the end of the day, the syntax is the same. It's this HCL syntax, HashiCorp configuration language, that you need to use, right? So it's actually a great tool if you're thinking about multi-cloud and you want to have some consistency around the technology that you're using. And also if you also compare it to only deploying on Azure, on ARM and on Bicep, the two main traits why people use it, in my opinion, is that the syntax is lighter, clearer, and easier. And also you don't have to manage the dependencies, which for some time that was a bit of a struggle in Azure. So in terms of history, going back, at first it was ARM. Around 2014, 2015, people started using ARM. Then because of the crazy syntax in JSON in ARM and because of the crazy dependencies that you have to manage by yourself in the code, people kind of switched to Terraform. That was probably 2017, in my opinion. I think that's when it started to gain traction, right? And it basically kind of blew up, if you call it like that. But in terms of traits, there are some similarities to ARM templates as well. You can use modular files as well. I mean, you can use, of course, a file per each resource that you're trying to build. In terms of dependencies, a bit different, as I mentioned. You don't really have to worry about it, and I'll show it to you in just a GIF because we're going to create it also on Azure, on Terraform. And the main difference is that it relies on a state file. What is this state file? Is basically a log of what you create. So when you create resources with Terraform, you basically create at a certain point a sort of a log, which concludes what you're going to build and what your infrastructure looks like. And then all of the future deployments will rely on that state file and will compare to that state file. So for example, if you're building a web app and a storage account, that will be your first state file created. And if you ever want to create at a certain point also a SQL server and you modify the Terraform, that the new state file that will be created by that Terraform will compare to the old state file and will just decide to add the SQL server. So it will not recreate or rewrite the web app and so on and so forth, right? But it's better shown than said. Let's go to Terraform because we're slowly running out of time. You'll see that in Terraform, the syntax, it's a lot lighter, right? So you just have some variables which are easy to read. You have to specify the provider, which in my case is Azure. If it's AWS, it's something else. If it's Google, it's something else. Also, the backend. The backend is basically where you will store that state file, that log file that I've been mentioning. And then you build the resources. The storage account, pretty simple. The file share, the service plan, and the web app, right? Main difference between ARM templates, as I mentioned, is that easier to read from a syntax perspective, and also dependencies. You don't see any dependency block around here that will say to me that the file share actually needs to wait for the storage account as we do it in ARM templates, right? If I go back to ARM templates, you will see that when I specify the file share, I am specifying this depends on, which says, okay, build me the file share, but only after the storage has been built, right? In Terraform, you don't really have to mess with that, right? So you don't really have to do that because Terraform takes care of that. Now let's go on building it. Before I do it in Azure, there is one, I wouldn't say downside, but something manually that you need to do in Azure so that you will keep the state file into the cloud, into Azure. And that's basically creating a storage account which will host that state file. So I'm going to do just that really quickly. I'm going to create a resource group named tf state. Europe. Let's move quickly because clock's ticking. Cool. Also creating a storage account. Which I will name it really intuitive if Azure goes through. Not here, into the TF state 025, something like that. West Europe, preferably. Great. I'm going to put it on local redundant. I'm going to skip directly to create. That should be fine. Great. Meanwhile, until this creates, just to save time, I want to show you that I'm going to do the deployment of Terraform through a CI pipeline this time, just for the sake of diversity. You can do it in a release pipeline, in a build pipeline, you name it. But the release pipeline basically looks like this. And you'll see that for every Terraform deployment, you'll have to do 3 main activities. So first of all, of course, you have to install the tool because it's a third-party tool, right? So that will be a first task. Then you'll have to do Terraform initialization, right? In which you're initializing the technology and you're also specifying where that log is going to be saved based on what resources you're going to create. Then your Terraform planning, right? Terraform plan, in which it will give you that log that I was mentioning you about, and it will offer you a summary. Look, this is what we're going to build. Do you want to proceed or not? You'll see how it looks like. And then Terraform apply, which actually deploys the resources, right? So you're first initializing the Terraform, then you're planning what you're building, right? And then you're applying it. Now you'll see that at a certain point that especially for Terraform init, in order to save that log file, that state file, how is it called in Terraform, you'll have to specify in Azure a storage account that has been built manually so that you'll have that state file that will help you in the future. I'm going to build also a container, which is called state.tf, right? And here my file will presumably be stored. All of these names of the storage account, the container, and also the name of the resource group, you'll see that they point to some variables. The variables are actually saved into a variable group in Azure DevOps. So if I go here into the library, you'll see that those exact names have actually been saved here by me before this session, right? And the file will be named, pretty simple, Terraform state. Enough said. Let's actually run the pipeline. It will build the same resources, but with different names, of course. So I'm going to run it, and you'll see that the things that I build with ARM templates are actually named pretty intuitive DevOps Pro Europe, whatever, 024, right? And the ones that I'm going to build with Terraform will be 025. So going really quickly, it's going to install the Terraform. It's going to initialize the Terraform. It's going to plan the Terraform, and you'll see how that summary of resources is going to look like. See? So it looks 4 resources to add, and these are the configurations that I want to do for each one of them, right? It's going to tell me, going back to plan, sorry for that, until it applies. It will tell me that the app service plan will be created with these kind of configurations. The storage accounts will be created with these kind of configurations, and so on and so forth, right? And when you draw the line, it will basically tell you, okay, great, I'm building all of these, 4 to add, 0 to change, 0 to destroy, right? Then it's applying them, and it's telling me in real time what is being created. Kind of like the tracked deployments that you do in Azure, but here it's in DevOps or into of course, the command line that you're using. So it's not really in Azure. If I go to Azure, you'll see that in terms of deploying, I'm not seeing what Terraform is building, right? So if I'm looking here, I'll not see any tracked deployments whatsoever. What that's happening in regards to Terraform. Okay. Also, I want to show you the state file that is being. You can also see that the resources are starting to be created. So this 025 is the Terraform one that it's being created. Also the web app, also the storage account. So they're spinning up. If I go to my TF state resource group, in which I have my TF state storage account, in which I have my TF state container. I've just named it that way so it will be easier for you guys to understand. Right? You'll see that here I have a file, Terraform state, which is basically that log file that I was telling you about. Right, Terraform finished. The resources are basically in there. That was Pro Europe. Takes a bit, right? The 025 ones are basically the ones created by Terraform. Now, if I go to my storage account, because I want to show you the difference between ARM and Terraform, and if I change blob public access and storage account key access to disabled, as I did with ARM templates, you will see that if I rerun my pipeline again, those will be corrected. Why will be those corrected? Because that state file that I was talking to you about in Terraform, that state file actually saved the configuration as those let's say properties being set on true. So when I rerun my pipeline, basically what I'm doing now, it will compare to what's actually being happening in Azure. It will compare to the state file. It will say, okay, these need to be reverted back to enabled, and it will re-enable them. That can be a pro and a con. I can say it can be a pro and a con because if you want to revert to your configurations in case somebody did something manually, well, it's an easy way to do it. You just rerun Terraform, end of story. But if you have people who have been creating containers or data or whatever, let's see what happened. It's also going to fail. See, for example, if I change in the properties, I also have this. You'll see that I can also have errors, but it's regarding the properties that I need to run. So if you do manual changes, right, I'm not going to emphasize on this. If you do manual changes, it might break your Terraform, or you might lose some of the configurations that you did manually in DevOps. So it's not incremental. It's not like ARM templates or Bicep, we'll see in just a GIF, in which you can say, okay, I don't care what's there. If I can change it, we'll change it. If not, it will remain the same. Terraform, once you go infrastructure as code mode, you have to do everything for infrastructure as code. Otherwise, you're kind of going to mess up the environment, more or less. Cool. 2 more minutes left. I'm going to talk really quickly about Bicep because there really isn't it really isn't too complicated. Bicep is basically ARM templates version 2.0. Going back to the history that I've been talking to you guys about ARM templates and Terraform. First it was ARM, then it was Terraform. Bicep came into the game somewhere around 2020. I think it kind of gained traction, and it was basically the response from Microsoft to all of the complaints from the infrastructure people, let's say from the DevOps people regarding ARM templates. People mostly complained about the syntax that is too heavy with the JSON, and also complained about the dependencies. So Bicep basically got rid of those. You'll see that the syntax is domain specific language. Sorry for that, which is a lot easier to understand. And also the deployments are sorry for that. The dependencies, you don't have to worry about them as long as you use them into the file. So exactly like ARM, only with the benefits of Terraform, if you want to put it like that, more or less, and without the state file, which can be a pro and a con. In terms of code, going to repos, just 2 more minutes and we're draw the conclusions. We're a bit behind time, but we'll manage to go through. Bicep basically looks like this, right? Pretty simple parameters to read. The block of the storage account, the block of the storage share, the block of the app service plan, the block of the web app. Kind of similar to Terraform, right? And you also, if you want to specify dependencies, you can specify dependencies. But if you're using one resource into the other, as I'm doing here, right, it's basically a dependency that Bicep will understand. So because I specified here that I'm going to use the ID of the app service plan, I don't need to specify anymore that the web app needs to be built after the ASP, the app service plan, is being built. So dependencies are also kind of managed by Bicep as well. Not the same thing as Terraform, of course, but it's going to that direction. Quickly, I'm going to build Bicep as well with a pipeline, which basically does the same thing. If I go to my pipeline, you'll see that it's the same as the ARM, pointing to the same artifact, having the same action, ARM template deployment, which points to my Bicep file this time. And I'm going to create a release, and my resources are going to be built. And you'll see that, of course, it will have all the traits that ARM templates has as well, but with some extra benefits. So until that is being built, let's go to the summary of what we've just discussed. Basically, the comparison kind of looks like this. In terms of what's standard for Azure, ARM and Bicep are built by Microsoft, so of course it's standard. Terraform, it's a third-party tool by HashiCorp, right? Which can also go into a slightly unhappy direction, meaning that at some point Terraform does not support anything in Azure. So anything that you build in Azure or new features or new services are directly supported and available in ARM and in Bicep. In Terraform, you have to wait until HashiCorp, the Terraform creators, have to support it as well, right? So you might end in the situation in which some resources cannot be built through Terraform. Simple syntax. I think everybody agrees that Terraform and Bicep, it's easy, while JSON and ARM is a bit complicated. It's a bit, let's say, more complicated to the eyes, right? Incremental deployments, which can be a pro and a con. I'll let you guys decide depending on your needs. You can do it in ARM and Bicep, but in Terraform you can't. State file, again, can be a pro and a con because it's kind of linked up to the incremental deployments. Terraform has state files, and you can manage that, and you revert to your initial state immediately, while in ARM templates or in Bicep, that can be a bit hard to manage if you're not doing it in another manner. Dependencies, as you can see, in ARM template, you have to specify them no matter what. Terraform, you don't have to worry about them. Bicep, if you're using interdependencies into the code, that will be resolved as well. Track deployments, you have it directly in Azure, although in Terraform you have it on the console, as you've just seen into my deployment. And extending with deployment scripts is that part that I was talking to you guys about, the PowerShells that can be run directly from ARM at a certain point at the start of the session. Now that's about it. I do have 1 more minute left, but I'm hoping we can go further for 3 more minutes to jump to a Q&A session. So please share your thoughts and tell me what's your opinion. What do you use? Terraform? Do you use ARM? Do you use Bicep? What are your concerns about any of them?
All right, fantastic. Thank you, Catalin. We do have one question already primed from Prasad Kumar. They ask
Mhm.
any tips on how to keep costs in check while creating resources from pipelines?
Yes, you can actually do that in Azure. At least you can do it with Azure budgets. So no matter what infrastructure as code or what DevOps tool you're using to build resources, or even if you're doing it manually, you can put alerts on budgets. There's basically a limit that you put on a resource group, on a resource, on a subscription. You can define the scope yourself, right? In which you can say, look, I want to spend this amount of money as a max in this amount of time, right? In a month, in a week, whatever. So, and also you can set the alerts that you're going to receive. So if you want to receive an email that you're 50% on the budget, you'll receive that. If you're on 100%, you'll receive that. So you can actually keep cost control with that pretty easy.
Okay. Well, one question I kind of quickly had in my mind is, we compared ARM, Terraform, and Bicep a lot. If you're talking to someone who hasn't used any of them before, right? If this is wholly new to them, what do you think is the most user-friendly one of the three?
Honestly, it depends what you're trying to achieve. So I'm a bit subjective to it. I'm going to be honest with you guys, because being a Microsoft guy, for me, the immediate response will be Bicep, for the fact that it's a bit more flexible to my needs, and also it also incorporates the pros that Terraform brought to the table back in the days when Bicep wasn't available, right? But at the end of the day, objectively speaking, it really depends what you're trying to achieve from an infrastructure as code perspective. Because if you really want to stick to the plan and correct manual things and never allow anybody to do manual things, you have that state file in Terraform, you can stick to it, right? If you're doing multi-cloud, again, Terraform will probably be the best choice. If you want to be a bit more flexible, and if you also want to do post deployments, and if you also want to, let's say, allow people to do certain stuff that are not just infrastructure as code controllable, Bicep would be my first guess. ARM templates, yeah, kind of lands into the second plan no matter what, because it's kind of the oldest tool yet available. So it's probably a debate more about between Terraform and Bicep now.
Okay, that's an interesting response. All right, I think that's all we're gonna have time for, though. We're already running a minute over, and
Sorry
we
for
do
that.
need to prep for the keynote one. But thank you, Catalin. You've been really informative. I love the way you were able to condense it down into such a small amount of time. I'm sure we walked away with some lessons. We appreciate you for coming on, and
Thank you for that.
look
And
forward to
yeah,
seeing what you
thank you. Nice meeting you. Bye, guys.